So this lesson is going to be about something called deductive reasoning. Now, that probably sounds a little bit familiar because we did just do a lesson about something called inductive reasoning, but they are two very different things, and I'm going to try to do right now, give you just a little sneak peek example as to what the difference between the two is, or just a way that you can think about it. So let's make a small little graph up on in the corner of your paper here like this. So this graph is going to be completely made up. There's nothing true about this graph. It's just for our purposes we're going to use this. Now, on the bottom here, on my x-axis, I'm going to write years. So these are years, every 10 years. I'm going to skip 10 years in between each one. And on the side, I'm going to write populations. So this is the year, and this is going to be the population of a city. Doesn't matter which city. It could be Alvin, it could be any city you want. Now, we're going to say that in 1990, the population of this city was 10,000 people. So 10,000. In the year 2000, the population of this city is 15,000. In the year 2010, population is 20,000. And in the year 2020, well, it hasn't happened yet, so we have no idea what the population is going to be. But I'm going to go ahead and write up here a prediction. I think that the population in 2020 will be 25,000 people. Now, when I decided that, or when I came up with that number, how did I do that? Hopefully you'll see, or you'll understand that every 10 years that goes by, we go up 5,000. So here's 10 years, 5,000. 10 more years, 5,000. So I'm just going to assume, I'm going to observe this pattern here and say that in the next 10 more years, we'll up 5,000 again. What am I using to do that observing a pattern? Hopefully you'll remember that is inductive reasoning, right? I observed this pattern. Now I'm going to write another statement. This is a conjecture up here. This is a statement I believe to be true based on inductive reasoning. So I'm going to write another conjecture. And it's going to say that the population in 2000 is 15,000 people. Now, do I need to observe a pattern to determine that? Or do I need to complete a sequence to figure out what it's going to be? Or do I need to look at the year 2000, go straight up, and see exactly what the population was? Hopefully, you agree that I didn't have to use a pattern to do this. This is deductive reasoning. Now, this is not the most amazing example that you're ever going to see of explaining inductive and deductive. I just want you to have a visual and a way for you to think about it. We, Mr. Lewis's geometry class, live right here in the year 2013. Right? So everything that happened here, these are facts, right? I could look this information up. Every 10 years, the U.S. government does a census. I could look it up. It's a fact, scientific fact, no doubt about it. Everything going this way is a prediction, right? This is what a weatherman does. A weatherman says, well, looks like this is what's been happening. I guess it's going to keep happening, right? So that's inductive reasoning. Inductive is when you predict. Deductive is when you use a fact or something that's known information. So we'll write that down real quick. Deductive reasoning is when you draw a conclusion from given facts, definitions, or properties. It just means you take something, you use it to get the answer, or use it to... So there's two main kinds of deductive reasoning that we're gonna focus on. The first one, and believe me when I tell you, just like about the last two tests, I told you things you need to know. You need to know how to use this, the law of detachment. This is a type of deductive reasoning. And it says that if P implies Q is a true statement, and P is true, then Q is also true. So take a minute and get that written down. Remember all the P's and the Q's? It's more important than you could imagine for the test that's coming up. Now, if any of your parents ever took a class, you can go ask them if they ever took a class in logic when they were in college. They could probably really help you with this. So we're going to come up with a little example of a scenario here. So, example. I'm going to say, if Becky, hopefully I don't have a Becky in any of my classes. If Becky fails geometry, then she cannot play volleyball. Okay, so we have a conditional statement here. If Becky fails geometry, that's our hypothesis, right? Becky fails geometry, that's our hypothesis P. She cannot play volleyball. That's our conclusion Q. Alright, then we have, so here's our statement. If Becky fails geometry, then she cannot play volleyball. Period. No, that's it. That's a statement. Now we're going to have another statement that says Becky failed geometry. Poor Becky, right? She should have made her flashcards. Alright, Becky failed geometry. Well, what logically can you now say is true based on the law of detachment? You can say Becky cannot play volleyball. Okay? So our hypothesis P, so right here, P is true. So that leads us to, or implies that, Q is true. So it's kind of like, this is what's going to happen if you don't do something right, and then here you did it wrong. So it's kind of like, it's like the cause and effect thing, okay? If this happens, then this is going to happen. Well, oh, darn, this happened. Well, now this is going to happen. It's kind of like you guys with watching these videos and doing your homework and all that kind of thing. I tell you, if you don't watch the videos, you don't do the homework, don't take good notes, you don't make your flashcards, you're going to fail the test. And then you come to me with your failed test, and Mr. Lewis, what happened? And from now on, I'm just going to reply to you, well, the law of detachment happened. All right? So that's one that you have to know. We're going to do one other one now. There's another law. This one is called the law of syllogism. Some people say syllogism. I say syllogism, but the law of syllogism. And it says if P implies Q and Q implies R are true statements, then P implies R is also a true statement. All right, so we'll take a quick look at how that works. So I'm going to write out a statement that, I don't know if this is how it is at your house, but if it was up to me, this is how it would be. If you fail your geometry test, then you will lose your phone. Okay? So if you fail your geometry test, then you will lose your phone. Now, we're going to write another statement that says if you lose your phone, then your life will be over, right? Wouldn't that be the worst thing in the world to lose your phone? Oh my gosh. It's making me cringe just think about it. So let's go through and identify our P's and our Q's and our R's. All right, so this just means if P, then Q. So if you fail your geometry test, P, you will lose your phone, Q. Now, the Q has to be the same in both statements. So here it says, if you lose your phone. So that's our Q. So if Q, then R. Then your life will be over. Boo-hoo. All right. The law of syllogism says that if P implies Q and Q implies R are true statements. So we have to assume both of these are true. Now, in your house, they're probably not, which is why you're still failing tests. But if they were both true, then we could say, logically, if you fail your geometry test, then your life will be over, right? And that is our if P, then R. And that's the law of syllogism. We're going to practice both of these a lot more, so you may have to watch it again, look back over your notes, but the basic concept is the same, whether we're talking about geometry tests and cell phones, or whether we're talking about line segments and angles. So come into class tomorrow with some questions about this.